Hello there, fellow coders. We're here tackling a more intermediate style algorithm that is kind of a natural extension of a previous one done on this playlist, which is actually, it might just be the previous video to this video, if I time my schedules up correctly. But if not, I'll make sure in the description down below there'll be a link to the steps video where we print a series of hashtags to form a set of steps in our console log. The logic and tricks we learn in that particular video will be very handy in solving this one called the pyramid, because it's kind of like half of those steps. So it's like two halves of those steps to make the pyramid. This one's a bit trickier than the print steps one, but when you see it broken down and understand where the logic is coming from, it'll make more sense. But basically, the idea is to write a function called pyramid that takes a numbered argument, n, which will be how tall the pyramid needs to be, and it prints a pyramid shape in console logs composed of the pound or whatever character. Typically, it is the pound or hashtag character. So yeah, clearly we're going to have some loop action going on here in order for it to be printed from top to bottom, and we're going to have some kind of dedicated logic to say, hey, are we printing a hashtag or are we not? So for an example here, if I call this with a pyramid value of 4 or something like that, let's take a look at what our expected output would be and see how we can make this happen. So we ultimately know that it needs to be 4 steps or 4 layers high, right? So to center these hashtags to make it look like a pyramid, we're going to have to make sure they are, well, pushed over some, right? So ultimately, this is going to look like 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so I know this math and the way it checks out, and we'll talk about it as we go through this particular little video here. But if this was the steps version, which again, technically it's not the exact same math, in order to make it the pyramid version, we would have to add some spaces, like so, in order to center the hashtags to build this pyramid, right? And so this is what our output should look like, and you saw me kind of build it in a similar capacity to how we are going to build each row that we're going to console log. So I have spaces here that bump these into position, but let's actually visualize these with some, just some hyphens instead, so we can visualize the space more accurately. Because you don't have to think, what about the right-hand side of the pyramid? Wouldn't I have to have spaces there? As long as it's centered, it honestly doesn't matter what those spaces are, what they look like, right? So all we have to do is say, hey, when we're printing each row of our pyramid here, I need to account for when do I print spaces to push and center my pyramid in each row, and when do I print hashtags, and how many hashtags do I print. So it sounds like we might have an outer loop that's going to dictate what level or what row we're currently on. We're going to have to write some logic and a potential loop that will have to go through and add the appropriate number of spaces and stops when when it's done the appropriate number of spaces. So sounds like another for loop. And then from there, we're going to have another for loop with some logic of when do I print hashtags and when do I stop. So the conditions will be when these for loops run rather than if-else style logic. And the for loops will there'll be 3 for loops in total. 1 to, again, handle the height, 1 to handle when to print spaces, and 1 to handle when to print hashtags. And then all of them working in unison is when this little thing is going to get printed out, right? So the idea is we're going to think of it kind of like building a block where each row of the pyramid has a different number of blocks, with the first row having just 1 block and the number of blocks increasing by 2 for each subsequent row. So keep in mind that you saw me count it because, again, I know the math, and this is one of those things you just kind of figure out while you do this thing. In order to keep like our elements centered, we have to grow each row by 2 additional blocks, aka my hashtags. So that's why I took 1, added 2 to get 3, took 3, added 2 to get 5, took 5, added 2 to get 7. So each row will have to grow by 2 blocks in order to keep things in a proper centered pyramid in our little logic here with our loops going on, right? So to keep the pyramid symmetrical, there are spaces on either side of each row to center it. We're just going to focus on the left-hand side to keep it centered. We're not going to write additional logic that will go on the right-hand side and add spaces because that'll be unnecessary for this particular little thing, right? So we're going to think of the pyramid function as like a machine that builds pyramids out of hashtag characters instead of blocks. The input n represents the height of the pyramid or the number of rows, which I'll be calling them in my code. The outer loop is going to act like our conveyor belt that moves each row into the pyramid in place, right? So let's go ahead and just code that out because that part's actually not all that difficult. So we're going to head into our pyramid function and we're going to write some of our first bits of code here. Like I said, we're going to have an outer loop that's going to write out the logic of printing how many rows there are. So we're not dealing with arrays and indexes and stuff like that. Oh yeah, I have my thing auto running, so it's running on incomplete code, hence the error that I'm seeing in my terminal over here. We're not working through array indexes and things like that, so let's not complicate the math by starting at 0. We're going to start at the value number of 1. That way we're printing the first row of said pyramid. And all we need to do is continue this pyramid so long as I is less than or equal to n, which is the height of our pyramid, right? So it's going to start from 1 and up to and including n, because that's how high our pyramid needs to be, aka 4 rows. And it's going to increment by 1 row at a time, and that's all there really is to it for that outer loop. And just like in the previous steps video, we're going to be doing some string concatenation to print out a value. We're going to be running some inner logic and some inner for loops to determine when we're printing spaces and when to stop, and hashtags. So ultimately what this thing needs to do is once all the other loops are done cycling through and adding the spaces or hashtags, it will print the row, then the outer loop will tick to the next row, and then it'll start the process over again, right? So that's why I said that we're going to think of that outer loop as that conveyor belt that just moves each row of the pyramid into place, right? Now, these two inner loops are going to act like robotic arms that add spaces, and the hashtag, the block characters, to each row before it's placed on the pyramid. So it's almost like we're building space, hashtag, and then print the row. Then the next row is like row is added into place. We go print, spaces, print, blocks, put that into place, right? Yeah, so that's what we're going to think of the first inner loop as. So we're going to kind of think of it as going to pick up a number of spaces and moves them in place to the appropriate row. Then we're going to focus on the second loop, which is, again, like another arm that picks up block characters and puts them into place, creating the pyramid shape. And then finally, every row is created like a block, and that each block stacked on each other is what builds that pyramid, right? That's how we're going to admire our beautiful pyramid once it is built out. So like I said, we're going to have two inner robotic arms, so to speak. They're going to be doing some kind of logic. For now, because I already gave you all this visualized output of what we're looking at, let's see if we can find some kind of logic that will end up determining when to print spaces. Then we're going to focus on trying to print the hashtags for this particular algorithm. Like I said, this one's a bit more complex, hence why I marked it as intermediate, which I hope doesn't turn anybody off from actually watching these videos here, right? So the important part here is to figure out how the math works. I mean, again, the outer loop is very simple. Starts at 1, goes up to n. That way we print out the correct number of rows, easy enough, right? Printing the spaces. That's going to be our first for loop, because clearly the spaces are the first thing we're going to have to be printing on each row in order to center this little pyramid here. Okay. The number of spaces needed for each row decreases by 1 as we move down the pyramid, right? That's fairly obvious. 3, 2, 1, none, right? So we can write some kind of easy logic that can account for that. We can calculate the number of spaces needed for each row by subtracting the current row number from the total number of rows. Okay? So how is that math written out? Well, it's going to look like the following. We're going to say, again, I can't use I, so I'm going to switch to my J as my iterator. Again, no crazy array indices we're going to worry about here. So we're going to start counting at the value of 1. And what needs to happen, and obviously we're going to be doing a iteration by 1 each time, no complex like curves happening here. We're just going to do a simple increment j by 1 every single time. The magic sauce that took me a while to kind of understand when I was first a newbie trying to learn these kind of algorithms to prepare for my first interviews before I got hired here is the following. We need to print spaces so long as, what did I say? We subtract the current row number from the total number of rows. Okay? How many total rows are we going to have? That is determined by that input argument of n. That is the total number of rows we're going to have, right? And then from there, we're going to subtract the current row number from that. what is the representation of our current row? That'll be the iterator variable I in the outer for loop. That tells us where we are in our current number of rows. Nope, not 1i. It is currently 1 for the first iteration, but there we go. That's our first for loop that's going to dictate when to print spaces. And as a matter of fact, it should be as simple as doing the following. String concatenate a space. In our case, we're going to do that hyphen so we can visualize it a bit nicer, like down here in the pyramid, right? So right away, I'm going to go ahead and clear this so I can be up above my head a bit cleaner. There we go. So yeah, check it out. We have the first half of the pyramid. If we look over here, we have the first half of the pyramid already going here. So again, let's, it's one thing saying it out loud, total number of rows minus the current row we're at. How does that math work? To generate this value here, let's actually just kind of poke around and plug in some numbers for each iteration of our outer and inner for loops so we can see how the math checks out. Let's start with the top row. So we have an input value of 4. We have our first row, which is a value I of 1. Then it comes down to the inner for loop, and it's like, okay, how many spaces is this mechanical arm putting into place to build out this part of the row? J of a value of 1. Okay, our math over here will be a 4 minus 1 to get a value of 3. Okay. Is J of 1 less than or equal to 3? It sure is, which means we print a hyphen. Then J increments to 2. Then it's still a truthy condition, which means it prints out a second hyphen. It gets to 3. Is that a truthy condition? It still is. It prints the third hyphen, and then J iterates to 4. I need to turn off my autosave so it stops printing things right over here and dragging y'all's eyes away from what I'm trying to teach. Okay, so like I said, J increments to 4. Is this a truthy statement anymore? No, it is not. Therefore, this cancels out and stops running the loop, and then it prints the row, hence how we get those 3 hashtags. Let's say we go down to the next row, so we have an I of 2. Our n is 4. 4 minus 2 evaluates to 2. Then we're going to restart our j back to 1. Is this condition truthy? It is. Print a hyphen. Then j iterates to 2. This is still a truthy statement, which means it prints a hyphen. Boom. Then j iterates to 3, and voila, this is no longer true, which means it stops printing hyphens. Then in our theater of our mind here, let's go ahead and increment to the next available row, which will be an I of 3. 4 minus 3 gets us a value of 1. J will reset to 1 on the next when the outer for loop moves to its next iteration, because remember, the key thing to keep in mind here is these for loops have to run to completion every single time. So when I say let's move to the next row, this is done running, the hashtags are done running, it's console log the row, the outer for loop ticks to the next value of I, which I said was what, 3? Or we already did that, right? Because I got to 3. So we get to value 4. 4 minus 4 gets us a value of 0, hence why we end up getting no hashtags printed for the bottom part of our row, which is that blank space right there. That's what we're looking at. So that is how the logic works for that outer for loop, right? The big key here is knowing that we have to subtract from our total number of rows, n, minus what row we're currently on, and that simply will decrease by 1 on every single subsequent row, hence why we get 3, 2, 1 hyphens. So that is how that logic checks out. So, like I had mentioned, we have a second for loop that we're going to have to deal with, and the math here gets a little bit more complicated, again, why I've marked this as intermediate skill level. That second inner for loop, and again, the important thing to keep in mind here is once these are done printing, we don't have to nest any kind of logic inside of it. We're going to have another for loop that's going to be running in tandem with that one. Now we could go ahead and use J again, but I'm going to choose not to try and avoid any confusion, because J is scoped for this for loop right here, which means I could reuse it in the scope of this for loop if I wanted. But to avoid confusion between these iterators, I'm going to instead choose to use a value of k, or a variable of k instead, so we don't get confused here, right? It's going to start at 1. Again, don't overcomplicate the math. We don't need to. And it's going to increase by 1 every iteration. And as we already know, its job is going to be printing our blocks with our mechanical arm, putting them into place. It has to know how many blocks to add for which row we're on. So clearly the logic and the magic sauce is going to be, once again, the second part of our for loop's conditions, right? That second part of when does it stop running the loop. So this math is a bit more complicated to get our heads around. So again, I'll describe what it's doing, show you the math, and then we're going to plug in some numbers so we can figure out how this is working, and hopefully our brains can wrap around it. In my case, when I was in your shoes as a student, unfortunately, I just ended up memorizing the answer. So if I ever got asked in an interview, I would be able to be like 2 times I minus 1 and just spit it out pretty quickly. But maybe y'all be a little bit better than me, hopefully, and figure out how this works as I kind of take you through it. So, all right, that second for loop is going to be printing our hashtag, our block characters, as we now know. The number of block characters needed for each row increases by 2 as we move down the pyramid, just like we saw. The top of our pyramid is going to clearly be only 1 block, and then we have to increment by 2 every single time so we can keep things centered as a pyramid shape. So 3, 5, 7, 9, so on and so forth, as we continue adding more rows to this thing. It'll keep growing by 2 every single time. Because again, if it didn't grow by 2, then we can't really center our hashtag for the first row compared to the second row. Hence why you're going to see it growing by 2 every single time. It's what allows us to keep things in a center, pushing our blocks over to keep them centered, and thus make that beautiful looking pyramid shape. So how do we calculate that number of block characters, right? What we're going to do is we're going to take each row that we're currently on, multiplying the current row number by 2 and subtracting 1. So once again, let's actually see what that looks like. It is going to be, so long as k is less than or equal to, right, the current row multiplied by 2, current row multiplied by 2, or we can do 2 times I, whatever floats y'all's boat, minus 1. Now remember, JavaScript follows the same PEMDAS rules that y'all are familiar with from grade school and basic arithmetic. Multiplication will be executed first. The product of this multiplication will then be subtracted by 1 after. So it's not 2 minus 1 to get 1, because that'd be pointless anyway, math-wise. So if it helps visualize it, we could do that right there as well, even though my formatter will keep removing it. So remember, that's actually what it's going to be, and we could always think of it like this as well, because that's going to be fine to change that order. That order of operations won't change anything, but is a bit easier on the eyes to look at. So how does this math work, and, well, does it actually work? Because as theoretically, my pyramid function is now done. Let's take a look at it and see if it works, and then we'll plug in some numbers and try and wrap our heads around how this math is working. But check it out. We'd have our lovely pyramid shape being built, and if I'm really fancy, I can just go replace the hyphens with spaces, and there is our completed result of this particular algorithm. But again, for visualization purposes, I will keep on including that hyphen because I think it's an easier way of looking at what we're doing here. So let me clear that out and go back up. Okay, so once again, the math, maybe you just have to memorize it, but hopefully you can begin to pick up and understand how it's working. 2 times our current row minus 1 gets us how many hashtags we wind up needing to print. So just like we did for the first for loop, let's see if we can wrap our heads around it a bit easier by plugging in some numbers as we iterate through. So let's say we're going to be focusing on our top row, which is an I of 1. So we come down yonder. We have a k of 1. We're going to say, is it less than or equal to 2 times 1, which is our current row, minus 1. Okay, so 2 times 1 gets us a value of 2. 2 minus 1 gets us a value of 1. Is 1 less than or equal to 1? Indeed it is. We get a row hashtag printed of, we print a hashtag, one of our building blocks. Then k iterates to 2. This is no longer true, which means the loop terminates. The row is then logged with the 1 hashtag placed into it, and the outer loop moves to an I of 2. So let's come back down here. Okay. 2 times an I of 2. K resets to 1 on the next iteration we get here. So here we go. This evaluates to 4 minus 1 gets us 3. And that's where that value of increasing by 2 every single time comes from. Multiplying the row by 2, subtracting 1, and we're always going to get the previous row plus 2, the previous row plus 2, the previous row plus 2. That's how that math checks out. But let's go ahead and build it out. Is 1 less than or equal to 3? And I think you can see where that 3 comes into place. It represents how many hashtags will be in this row, so we can speed through it. This is true, prints 1. This is true, prints 2. This is true, prints 3 hashtags. That's how that checks out. Let's go to the last row and be done with it, or the second to last row, and we'll probably stop it from there because we'll understand how this works. I will increment to 3. So we get what? 2 times current row, which is 3, minus 1. K resets to 1 on this iteration for the new row. 2 times 3 is 6, minus 1 is 5. And we can see, again, previous row plus 2. That is how this math checks out, because we know that each row has to add 2 hashtags, and this is the math that does it for us. So once again, if it is less than or equal to 5, it prints it, and that's how many hashtags it prints. 1, 2, 3, 4, and 5 hashtags it does indeed print. And then the final row will be a 4, so we can get a 2 times I of a current value of 4 minus 1. That evaluates to 8 minus 1 is 7, and that's why we print 1, 2, 3, 4, 5, 6, 7 hashtags at the bottom of our pyramid. And again, that is this algorithm in a nutshell. Help, I'm an algorithm in a nutshell. But that's the whole purpose of this thing. It is a bit trickier, but once you understand the math of when to print spaces, or in our case hyphens, just for a fun visual aid, versus when you print the blocks for our pyramid. So the way I tend to remember it is remembering that we print 1 less space per row. So all I have to do is take our total number, subtract I, because I will increase by 1 every time. So because we're subtracting from n every single time, the number of spaces will go down by 1 on every single row. Okay? And then, like I said, in order to actually center a pyramid, we have to make sure that we're having an odd number of characters for each row. So we simply take the previous row and add 2 to it, right? So hence why we get 2 times current row minus 1 winds up always being, again, 2 times the number minus 1 gets us previous number of hashtags plus 2 is how that math basically works out. So yeah, I hope this has been a fun one for you guys. Again, it's a bit more advanced, but when you break it down into step by step, pun intended for our pyramid block shape here, step by step, right, row by row, it's not too bad to wrap your head around once you understand how that math is working and what its purpose is doing, right? So remember, we have an outer conveyor belt for loop that generates each row. Then we have an inner for loop, like 2 robotic arms. The first inner for loop plants some spaces so we can center our pyramid. The second for loop is the other robotic arm that adds the appropriate number of blocks to make that beautiful pyramid shape, right? And then finally, we just log the row to the console and move on to the next row, and until we complete it, that's all there is to it. So yeah, hopefully you've enjoyed this next video in the Conquering the JavaScript interview series. This is a really good one to know how to do. Again, even if you just memorize 2i minus 1 and then also n minus I as your logic pieces and just kind of call it a day, like maybe put them on some index cards or post-it notes and quiz yourself so you can just memorize his answers. This one, I've had a student been asked before. Again, I don't really think this relates to the actual work you're going to be doing as a JavaScript or just a programmer in general, but we all know that this is how the interview process works, so we're going to learn to min-max our ability to pass the interview to get that first job or your second, third, whatever job. Again, they like throwing out questions like this, and we're here to prepare for that, so when the opportunity arises, we have made our own luck. So ta-ta for now, folks, and I'll see y'all in the next video.